Okay, this is the first lecture for MECH 3323 Instrumentation and Avionics, and I will just cover part of avionics in this lecture. So today is the first introduction. First of all, I would like to introduce what is avionics. Avionics is actually a short form from the combination of words between aviation and electronics. So if we take aviation and electronics together, we get avionics. But technically, avionics will cover three parts of purposes. The first one is the navigation, second is communication, and the last one is surveillance. Okay, what is navigation for? Navigation is actually a field of study that focuses on the process of monitoring and controlling the movement of a craft or vehicle from one place to another. Okay, in this case, when we are talking about aviation navigations, means that we are in the process of monitoring and controlling the movement of an aircraft. So an aircraft is technically will be defined is if either it is an airplane or a helicopter or a drone itself or UAV. Right now we have a lot of UAV. So navigation is playing a very important part when we have to monitor and controlling the movement of the aircraft itself from one point to another point. Okay, we have another one which is communication. So communication is the act of conveying meanings from one entity or group to another through the use of mutually understood signs, symbols, and semiotic rules. Of course, we are not only when we are talking about a flying aircraft, it's not only one aircraft in the sky, but we do have a lot more than one at one location. So we need to have a very good communication. So the best one is through the electronic device, in which we when we have a communications, means that we know at what uh, position, what is the situation in the aircraft itself. So the even an aircraft can communicate with another aircraft pilots. So even from the with even the pilot and the ground station itself. So communication plays a very important role because we are now not only flying in one place but in another place as well. Okay, next we have surveillance. Surveillance is the monitoring or close observation of behavior, activities, or information for the purpose of influencing, managing, or directing. So basically, this is related to the application of a camera. It's an electrical device that attached to the aircraft. In this modern world, like in current era, we we have a we very good technology in terms of camera, in which we have a image processing that we attach to our drones or UAV in order to have a close observation on several illegal activities, or in order to keep our sovereignty in a key place. So uh, so surveillance play one of the thing that very important right now is about the camera itself, in which we can say that one as the one of the aviation electronics devices. Alright, since we are talking about avionics, the avionics industry itself is a major multi-billion dollar industry. We consider that as a worldwide industry, and the avionics equipment itself accounts for annual for around 30% to 40% of the total cost of the aircraft. So it become more expensive, up to 70% of the cost for airborne early warning aircraft. So this is a special aircraft. But we need to answer one question: why avionics system are essential? Uh, Based on the summary, to summarize this slide, It is to carry out the flight mission safely and efficiently. So if we look into two perspectives, for example, civil aircraft and military aircraft, they might provide us with different mission. For example, for civil aircraft, the mission itself is to carry passengers from one location to another location. It's either domestic or international aircraft, aviation system. But for military aircraft, the surveillance and recognition is very important to patrol some areas, and then to intercept a hostile aircraft or attacking, most likely for combat mission. And then ground target avionics instrument is very important. So it become more demanding for the avionics instrument of the military aircraft. See, because we need to provide several type of integrated avionics weapon system like sonar, radar, military communication system, and then combat system, and the last one is tactical missile guidance. Uh, but actually, I believe that every one of us have been into the aircraft itself. But why do we have to switch off our handphone or our mobile phone when an aircraft is below 10,000 feet, which is this is might be the cruising altitude? To answer this question, the aircraft avionics have sensors that communicate information to the cockpit instruments. They are receiving signals and transmitting signals to the ground station. This is at very high radio frequencies. So some gadgets, handphone, laptops, and etc. also emits this kind of radio wave. Although we use that at different frequencies, if the frequencies emitted by the devices are close to those of the avionics, there will be signal interference and corrupted reading by the sensors. Okay, in avionics, there are several terms that we need to memorize, or we need to be very familiar with this. For example, NDB, non-directional beacons. So beacons is actually most likely is de a device that transmit the electronic that transmit signal from one to another device. For example, if we are talking about the pilot in an airplane with to the ground station, so we use beacon as the way of transmitting the signal. Okay, we do have another one which is VOR, very high frequency, VHF, omnidirectional range, and then DME, distant measuring equipments, because the sky is open wide. We're not really sure at what distance the aircraft is actually traveling. So we need several type of equipments that can measure the distance, the range, and the altitude itself. So this is one type of avionics that been embedded in the aircraft itself. Okay, we also have TACAN, Tactical Air Navigation System. This one most likely we use in a military jet aircraft. Okay, because we are involving with military exercise. And then we have Lorenzi, which is a hyperbolic radio navigation system that allow a receiver to determine its position. So they transmit a low frequency radio signal by fixed length. This is related to the radio beacon as well. We also have ILS. So ILS is actually instrument landing system. Okay. We also have MLS. Then we have GPS. This one everyone know. GPS. Then we have autopilot. Of course, today in current situation, everyone is talking about the IR 4.0 industrial revolution. Everyone need to be autonomous, even in the on the ground vehicle cars. We do have an autonomous car. When we are talking about aviation as well, we need to have a very good system in terms of autopilot. So then we have gyroscope. Gyroscope is for the stability, most likely for when an aircraft, like example, is hovering on into the sky. And then altimeter radar, and then the last one is Doppler, right? So history in 1925, we say that one is a flying blind, means that we just have an aircraft without any avionics system installed in that aircraft. That's why we say flying blind. We don't know what is our situation, at what angle, at where is the position of the aircraft. People don't know about that, and even we don't have the communication between each other. So that will be very difficult if you want to have a very good combination. If of course when you fly more than one aircraft, you want to have a very good coordination between one aircraft and another aircraft. So there is some kind of limitation in terms of flight, in which we just allow the aircraft to fly in the clear days. But how about in the rainy situation, or in the dark night mode situation? It will be difficult for us to fly. So in 1937, someone proposed altimeter, in which it avoid unseen mountain, because altimeter always measure the distance from the ground to the flying aircraft. So we can measure the mountain based on that altitude. And then also for landing at fog bound airport, because due to clear vision, otherwise we don't have a very clear spot to land the aircraft. And then in which they propose reference to the natural horizon. Okay, so the proposed altimeter also avoids misorientation, in which being fooled by the force developed by the AC aircraft turn. Okay, in 1929, the radio comes. This is about the communication, radio navigation and communication. The radio come of the age. So here the first thing they introduce NDB, a homing beacon. Okay, and then it's keep evolve in 1930, beginning of the National Airspace System. So now we have the application of radar, ground station, in which you can know you can communicate with the flying aircraft, which is very far away. And a good stuff in WW2, World War II. Okay, secondary radar, we say IFF. And then we have ATC, Air Traffic Controller, radar beacon system. Until today we use this. And then next, it can become evolved based on every application. We have VHF, VOR, ILS, LORAN, onwards, and starting from 1950. And then the most popular right now, we have GPS. So GPS plays important role until now. So GPS is actually global positioning system that being evolved from the application of aircraft. Now we use even in our Google Maps, in our in other application for us to reach our destination. Okay, so aircraft navigation principle, the first one is dead reckoning, navigation by extrapolating, in which to determine the present position through the knowledge of a previous reference position. So aircraft is actually flying not consistent, like this. At one instant you might fly an aircraft at several altitude, and then you might reduce the altitude itself. So navigation by extrapolating means that you need to know the present position and the previous reference position so that you can extrapolate where is the location in the middle of between that two position. So we can use this technique to determine where are you by knowing where you have been, and then based on that also we can identify how fast you are traveling, and then the direction that you follow. Okay, we also have initial NAV navigation. NAV is initial navigation based on double integrating the aircraft acceleration measured using airborne equipments. For example, airspeed sensor, rate sensor. Rate is with respect to time and etc. Also, radio navigation, navigation through the use of wireless communication signals broadcasted by ground or aircraft-based radio station. Okay, it's not only aircraft, or we said aerospace vehicle is not only restricted to an airplane, helicopter, and so on, but also satellite. So satellite navigation through the data, the use of data broadcasted by a satellite-based transmitter. So satellite is also considered as one of aerospace devices. Okay, because this is just introduction, so we need to know what kind of body or regulatory and advisory agency that involved in giving the what I call a standard in terms of this avionics or aviation electronics devices. For example, this in current situation we use ICAO. ICAO is the International Civil Aviation Organization, which is a United Nations organization, and then they develop a standard for aviation matters. So means this is the worldwide standard. So standardize, they play roles in standardizing the signal in space for ground transmitting instrument. For example, LLS. And then they also provides international agreements for air traffic control, ATC worldwide. Okay, the aircraft nowadays is not only traveling. For example, if I take Malaysia, it's not only domestic distance, but we are traveling world in the international borders and so on. So ICAO plays a very important role for the ATC, like in Malaysia or Singapore. So how can we have the agreements in terms of the national in terms of our borders of airspace. So this is the responsible by ICAO. They have to determine at what altitude, at what in which what is the border between one country to another one. Okay, so that's why we said that ICAO is very important in defines country airspace. Okay, we also have IATA, International Air Transport Association. Okay, now this is a very popular because most likely the aircraft is being manufactured in Europe. So EASA, we have EASA, European Aviation Safety Agency. Most likely countries in Europe use this kind of regulation. Okay, we in terms of national aviation bodies, we have FAA. FAA is a Federal Aviation Administration, which is located in United States. This one also very popular. If you want to design an aircraft whatsoever, we need to refer FAA. And then we have NTSB, National Transportation Safety Board. NTSB is mostly also very popular when it involves with a crash or a crash like investigation, why the crash is happen, and what and then they have to investigate that kind of situation. Is it either the fault or the crash due to the pilot or the electronic devices inside the aircraft, or the technical problem inside the aircraft itself. Okay, we also have Transport Canada Civil Aviation. This is local, because local in Canada. What I mean is local in Canada, Transport Canada Civil Aviation, in which the same like we have what we have here in Malaysia is Civil Aviation Authority of Malaysia, CAAM, or formerly known as Department of Civil Aviation, DCA. If you want to relate this, they are, for example, when we have the missing airplane MH13 370, the Malaysian Airlines flight. So during that time, if I'm not mistaken, in 2014, that fly from Kuala Lumpur International Airport to its planned destination, Beijing Capital International Airport. So they are the one that responsible to get involved in the investigation where the aircraft is flying and what is the problem that involved, why is the aircraft is missing and so on. So last time we said Department of Civil Aviation, or in Malay we said Jabatan Penerbangan Awam. Now they have changed the name, Civil Aviation Authority of Malaysia. Okay, this is the basic flight instrument in avionics. This is just a basic, so means that maybe this is just the requirement for example, for a small or light aircraft. So basically, this is, if you don't have this, the aircraft is not permitted to fly. Okay, so basic flight instrument here is the first one is Pitotstatic instrument. Like we understand that Pitotstatic is measuring about the pressure and so on, right? So it consists in 1, 2, and 3. For example, in airspeed indicator, and then we have also altimeter, and the last one is vertical speed indicator. You see there 1, 2, and 3. So it means that in this part, airspeed indicator, altimeter, and vertical speed indicator, there are several Pitotstatic instrument here inside. Okay, and then we also have altitude instruments. Altitude instrument in 4 and 5, which is the artificial horizons 4, and then turn and bank indicator here 5. Okay, just to measure the altitude. And then HDG instruments in 6 and 7. HDG is actually a heading instrument. So it consists in directional gyroscopes and 7 magnetic compass. Okay, so what is we can go one by one. For example, Pitotstatic instrument system, device driven by static pressure and pitot pressure obtained from the pitotstatic tube. Okay, so we have a pitotstatic tube here is N it is an open-ended tube. So one's closed and the other one is open. That's why we say open-ended. Means that one closed and the other one is open. Tube where moving fluid flows in order to measure the stagnation pressure. So you might cover this in aerodynamics. If I'm not mistaken, in aerodynamics is about the pitotstatic and so on, right? So pitotstatic tube is mounted under the wing. So this is also in aerodynamics. This is very important if you want to have a testing in wind tunnel. But here in avionics, we do have that application in which we mounted under the wing to measure all the pressure, the stagnation pressure. So here we use the Bernoulli equation as constant elevation, assuming ideal uncompressible fluid. What is uncompressible fluid? Uncompressible fluid is actually the rho is the same. Means that the air density is the same. It will be constant. Okay, that's why we say constant elevation means that that one will be in measure in terms of the same altitude. Okay, this is the equation that used to calculate the pressure PD. Rho times V square divided by 2. So PD is dynamic pressure. This is actually taken from Bernoulli equation. Okay, what is PS? Sorry. PS is static pressure. And then the pitot or total of stagnation pressure is actually the summation of PS, the static pressure, and the dynamic pressure. Okay, from here, technically when you fly, since they mentioned that the pitotstatic tube is mounted under the wing, so that one, the pitotstatic tube will measure this kind of thing. The airspeed indicator, the altimeter and vertical speed indicator by using this mechanism. Okay, these instruments are based on the using pitotstatic tubes to measure the dynamic pressure or change in pressure. Okay, we have altitude instrument. These instruments are based on using a gyroscope to indicate the rolls and pitch of an aircraft. Okay, we have the artificial horizon. Why we say artificial horizons? Because we need to have a standard in which in this case is the horizon itself or the atmosphere. We use the natural, what we call the natural indicator, since the aircraft is flying out in everywhere in the space, so we need to have a good measuring point. Okay, so the gyroscope is plays a very important role in turn and bank indicator, either it's going to the left or to the right. Next, we have heading instruments. These instruments are used to indicate the aircraft headings. So here we have a directional gyroscope and magnetic compass. So technically everything is just being summarized in this figure. Whatever that they have put here, the indication is actually everything is in this figure. Okay, now let's cover this part. Visual flight rule, we said VFR, and instrument flight rule, IFR. Okay, visual flight rule, VFR is based on flying by visually looking out of the cockpit. So visually navigate with reference to the ground landmark means that the pilot is himself checking outside throughout the window. And then aircraft altitude control may be based solely on the natural horizon visible throughout the windscreen of the aircraft. Okay, looking out to avoid collision with another aircraft. Okay, this is some kind of limitation if you have another fog or so on, so that might be a problem to the pilot himself. So VFR flight usually involves small aircraft operated for personal purpose. Why this is for a small aircraft? Because they are not flying above like more than 20 feet, 30,000 feet, or 30,000 feet. It's just like very low altitude. So the visual is still we can see whatever obstacle that in front of us. Okay, but here IFR we have instrument flight rule. So the short form of instrument flight rule is IFR, which is based on flying using airborne instruments. Okay, so aircraft must be equipped with gyroscope, navigational equipment, radio communications, radar transponder, and etc. Okay, IFR operators are fully controlled by air traffic controller, air traffic control (ATC) systems. Okay, ATC operators on the ground give directions for each aircraft, flight plan, navigation, cruising altitude for traffic separation, departure clearance, and landing clearance. So IFR is very important for a big aircraft that we use, for example, Boeing or Airbus themselves. So everything is being controlled by air traffic on the ground station. What is the direction? They are just like a GPS to the pilot. So the pilots must have a very good communication with the air traffic controller. Uh, if we learn what we learn in our flights, or interaction to the flights, we might have some kind of mechanism in landing or departure clearance. For example, in aerodynamics, if there is some kind of turbulence occurs on the ground or unsteady flow, something that might disturb the stability of the aircraft, so the aircraft is not permitted to land. Who's going to give the instruction to them is actually the air traffic controller. So by using this instrument flight rule.